Okay, so this is the last section for linear relations, 6.2 part 2. And today we're going to look at using linear relations, so using equations and tables of values, graphing them, and analyzing them. So that will be our focus for today. Typically in math, we will be using line graphs. So either continuous or dots. They tend to be more appropriate than bar graphs or pictographs or any other graphs that you might have seen. Let's go into example 1. So Aaliyah is babysitting for the Negras. They're going to pay her $6 an hour plus a bonus of $10 because these kids have a lot of energy. So part A, let's make a table of values. She wants to make a table of values to see how much she will earn. So let's start with that. Okay, so we always have X on the left and Y on the right, and she gets paid $6 per hour. So our X axis would be the independent variable, which is time, and it's being measured in hours. And then on the y-axis, it's money earned. And it is in dollars, which would be on the y-axis. So just for coming, she gets a $10. Okay, and then for every hour that she works, she gets paid $6. So if she worked 1 hour, she would make $16. If she worked for 2 hours, she would get paid 22, and so forth. So for 3 hours and 28. So there's our table of values. And what we're going to do in part B is we're going to graph the ordered pairs. So when we're graphing, it's very important to adjust the axes to make sure that the graph takes up a lot of space. The graphs are the way that we communicate numbers to people, right? So oftentimes all the graphs that you do see, the graph itself would take up the coordinates that you plot would take up the whole grid, or as much as possible. So we have to spend some time thinking about what we want our X values to go up by and what we want our Y values to go up by. Okay, so here we go. I'll walk you through this. So this is my X-axis. And this is my y-axis. So notice I'm not splitting the grid into 4 quadrants. It's because we're dealing with time, and I know that time cannot be negative, and same with money. Money cannot be negative. So there's times where you'll be making your axes on the edge, and other times you might be making it down the middle. So our x-axis is time in hours. So we always put the units in brackets, and on the y-axis it's the money earned, and we are paying in dollars. Okay, so we've got our x-axis or y-axis, we've labeled them. We also need a title, so babysitting money earned versus time. Something that describes what's going on in the graph. And now let's look at our time here. So we go from 0 to 3. So it wouldn't make sense, so this will be 0. It wouldn't make sense to have 1, 2, 3, 4, because then our graph would be squished in this area here, right? So we want to spread it out as much as possible. So I can do, let's see, you know what, every 4 I can do 1 hour. So 1, so that's 2 hours. That's 3 hours. And then the 4th hour would be just off the grid. Right, so it's important to play around with your scale. And then money earned, we have 0 as well. And it looks like we go from $10 to $30. So here I'm thinking maybe I can go up by 2s. So 2, 4, 6, 8, $10. 2, 4, 6, 8, $20. And 2, 4, 6, 8, and that would be $30. So it looks like my coordinates will space themselves out nicely. So like I said, that is a skill that's learned, how to adjust the axes, and it just takes time. Make sure you're doing this in pencil, because chances are you will erase it a few times. And now what we're going to do is graph the ordered pairs. So I'll use a different color for that. Okay, for time 0, we have $10. For 1 hour, we have 16. For 2 hours, we have 22. And for 3 hours, we have 28. Okay, and notice it is a straight line. Okay, so what is the equation of the line? So this is something that we've practiced over the last few classes. We use our, we start off with this here, y equals something, x plus something, and this value here is when x equals 0. So we know that that's 10. And now we go to our table of values. We know that we have to add 10 every time. So what do we do to the 2 to make it 22? Knowing that we have to add 10. What do we do to the 3 to turn it into 28? Knowing that we have to add 10. And it looks like we have to multiply them by 6. So 2 times 6 is 12. 12 plus 10 gives us 22. So we have y equals 6x plus 10. And I could also rewrite this as m equals 6t plus 10 as well. Money earned equals 6 times the number of hours plus 10. Okay, so that would, in part D here, estimate how much she would make for 3.5 hours of babysitting from the graph. So let's go back to the graph here, and 3.5 hours, so this is 3 and this is 4, that would be 3.5. So what I would do is, at 3.5, I would just draw a line up to the graph, where it hits the graph, and I would then draw the line to the y-axis. Looks like it goes a little bit over my grid here, but I mean, I'm just estimating. So I estimate this here looks like it's about, I'm going to say about $32. Okay, and then when we look at, actually I'll get to that in another part. Part E, calculate how much she would make after 3.5 hours of babysitting. So with that, we can use the equation m equals 6 times t plus 10. And for time, we plug in 3.5 3.5. So 6 times 3.5 plus 10 works out to $31. So she would make $31 for 3.5 hours. Okay, so that's example 1. Let's move on to example 2. Okay, so with example 2, we have a skydiver who jumps from an airplane. There's a table provided here with some information. It provides us data for the period of time shortly after the parachute opens. So after 10 seconds, he or she has descended or gone down 300 meters. After 11 seconds, 354 meters. After 12 seconds, traveled 408 meters, etc. Going down. And looking at this table of values here, we go up by 1 second. And for our distance here, 300 to 354, we're going up by 54. So the difference between the distance for each second is 54. So part A, predict how a graph for these ordered pairs would look. So we can say that the graph would be linear because our x values and our y values go up or down. In this case, they go up by the same amount. So the graph will be linear since x and y values go up by the same amount. Okay, and before we go to graph it, I just wanted to point this out here. When we have a table of values and the numbers start at a larger value, so for example here, our distance started at 300 meters. What we can do, we use a break, and it's just a symbol to show that we are skipping values. So I'll just show what that looks like here. So this is my y-axis, and this is my x-axis. If I wanted to put a break in the x-axis, I would make this symbol here. So up, down, up. And that shows a break in the x-axis. And same thing with y. If I wanted to show a break in the y-axis, I would use that zigzag line here, and that tells me that there is a large jump. Okay, so we're going to use this to graph the above example. So graph the ordered pairs. Okay, so let's start with figuring out what we put on our x-axis, y-axis title. So we have time in seconds, and on our y-axis we have distance descended, and that was measured in meters. So we always use brackets for our arrows, brackets for our units. And both x and y are all positive, so we're going to start our origin here in the corner. We need a title, so we can say time versus distance descended. For a skydiver. Okay, so let's look at our grid here. We have a 10 by 10 grid. Okay, and our seconds, if we go to our table of values. We have from 10 to 13. So what I would do is so this is 0. We'll put a break in here. And then we'll start at 10. And I think we can go over 2 for each second. So that's 11, skip 2, that's 12, 13, and 14 seconds, right? Because if I didn't put the break in and I squished all these numbers, then my graph would just be in this general area here. Distance descended. So we start at 300 and we go to 462. Okay, so we definitely have to put a break in here as well. And we can start at 300 and we have to go up to a little bit over 462, right? So you have to play around with the scale, count it out, and I did it a few times, and first I thought, okay, I'll go up by tens. I realized it wouldn't, the graph wouldn't fit on here. So then I thought to go up by 20s. So this is 300, this is 320, 340. Now you don't have to go through and label each one like I'm doing here, but I mean, if you want to, that's fine as well, since we're just starting out. 420, 440, 460, and 480 at the top. It's just a little bit messy. I should have maybe skipped one, but okay, so let's graph the coordinates. So I'm going to pause it. I'd like you to plot the coordinates. Okay, so you can double check your coordinates with mine. You had to estimate at times. So for example, 354 is in the middle here, but just slightly above, because the middle would be 350. And then what I'll do is connect these dots here. Oops, I skipped here. Part C, does it make sense to connect the dots, right? Because we have discrete graphs and continuous graphs. In this case here, yes, it does make sense to connect the dots because we can have all values of time here. So we could have 10.5, 10.6, 10.7, etc. Time is continuous. So we can have all values of time. It's a continuous graph. And estimate the distance descended at 11.5 seconds. So I go to my graph here. This is 11.5. Once I hit the graph, then I take a left to the y-axis. And it looks like it's about 380 meters. Now, if I had, we didn't write the equation out for this one, but if I had, I could have used the equation to find the exact time and describe the graph in words. So we can say for every second increase, the distance increases by 54 meters. Okay, so that's it for today's lesson.